Hi guys, welcome back. So today's video is going to be over hybridization, specifically a little trick that really helped me when I was taking OChem in undergrad. And I understand this topic may seem a little hard at the beginning, but I promise this really is easy, especially with this trick. So let's go ahead and get into it. So first, we're going to add the number of bonds and potential lone pairs. Then we're going to subtract 1 from the sum. And then we always want to remember that resonance takes priority. If our sum is 4, then our hybridization is sp3. If it's 3, then it's sp2. And if it's 2, it's sp. Another thing that we want to keep in mind when using this trick only is that obviously if it's one single bond, we recognize that as one bond. But when we're counting the way that I'm about to teach you, we want to remember, well, first off, as chemists, we understand that when we see a double bond, that is 2 bonds, right? But when we're using this trick, we're going to count this double bond as one single bond. Same thing with the triple bond. We understand that this is 3 different bonds, but when using this trick, we count this entire thing as one bond. This will make sense right now that we get into some examples. So let's start with this one. Let's find the hybridization of that nitrogen atom. First, remember, make sure you have the correct number of bonds and potential lone pairs. I was nice enough and I drew some of the hydrogen bonds for these problems. Remember, a lot of professors aren't going to do that. You need to be able to know how to do that and make sure you know how to recognize the correct number of lone pairs. But when we look at this example, everything looks fine. So let's go ahead and count the bonds and potential lone pairs. We don't see any lone pairs, so we're just going to count the bonds. 1, 2, 3, 4. 4 minus 1 equals 3, or in this case, sp3. What about this carbon? If you realized that there's a hidden hydrogen bond there, then you're doing well. Let's go ahead and count. 1, 2, 3, 4. 4 minus 1 equals 3, or in this case, sp3. Let's find the hybridization of that oxygen. Make sure bonds and lone pairs are correct. Everything looks good. So let's count. Remember, we understand that this is 2 bonds. But when we're using this trick only for hybridization, we count that whole thing as 1 and the lone pairs as 1 as well. So you'll see right now. 1, 2, 3. Again. 1, 2, 3. 3 minus 1 equals 2, or in this case, sp2. Let's do these carbons right here. Make sure bonds are correct and potential lone pairs. Everything looks good here. So let's count. Let's start with this first carbon. 1, 2, 3. 3 minus 1 equals 2, or in this case, sp2. Let's do that second one. I have it written down as CH2, but remember that that means this. 1, 2, 3. So again, 3 minus 1, sp2. Let's move on to these carbons right here. Make sure bonds and potential lone pairs are good. Everything looks good here, so let's count. 1, 2. Again. 1, 2. So 2 minus 1 equals 1. In this case, sp. And we will see the same thing with this next carbon. 1, 2. 2 minus 1, sp. Let's find the hybridization of that carbon right there. Make sure bonds and lone pairs are good. Everything looks fine, so let's count. 1, 2. 2 minus 1 equals sp. Now remember when I said that resonance takes priority? We'll see that right now. Let's find the hybridization of that nitrogen. Again, make sure bonds and potential lone pairs are right. It looks good here, so let's count. 1, 2, 3, 4. So when we see that, we might think that is 4 minus 1, which equals sp3. But that's wrong. And the reason that is wrong is because that nitrogen has resonance, which looks like this. Meaning that we would get a double bond here, and then this nitrogen would get these lone pairs. So in reality, we have 1, 2, 3. Let me do that again. Because of the resonance, these lone pairs here don't exist anymore. So we count 1, 2, 3. And 3 minus 1 equals 2, or sp2. So that's the correct answer, because resonance takes priority. Let's do another example. Let's find the resonance of that oxygen right there. Again, if we just count 1, 2, 3, we would assume that that's sp2, but because there's potential resonance, that's not our answer. We have to push arrows. When we push arrows, it looks like this, which would look like this. So now let's count again. 1, 2, 3, 4. 4 minus 1 equals sp3. And that's the oh, that looks really ugly. sp3. And that's the correct answer, because resonance takes place, or takes priority, sorry. Another thing to keep in mind is that if our hybridization is sp3, the angle is 109.5 degrees and the shape is called tetrahedral. If it's sp2, it's 120 degrees, and that's known as trigonal planar. And if it's sp, that's 180 degrees, and that's known as linear. I would suggest go ahead and make flashcards for these and just memorize this, because in exams, professors, yes, they're going to ask you hybridization, but sometimes they just might ask, hey, what is the angle for this? Or what is the shape name? And you guys might hate me, but I am asking that in this question that I want you guys to do by yourself. I will post the answers in the description. Remember, follow the trick. Make sure your bonds and your potential lone pairs are right. And go ahead and find the hybridization, the angle and the shape for A, B, and C. Thank you so much for watching. I hope this video was helpful. Please like and subscribe, and feel free to comment below any other topics that you guys want me to go over. Thank you so much.